turn ahead to oxidation numbers. And honestly, we've already talked about oxidation numbers. What are our oxidation numbers? The charges. Okay, it's the charge on your periodic table. So when you look at your periodic table, for you guys, it's the little numbers in the top right-hand corner. Okay, those are the oxidation numbers. So in some cases, some elements have more than one oxidation number. In a lot of cases, some elements just have one oxidation number. Okay, so oxidation numbers are the potential charge that an element may have when it's with somebody else. Okay, so like for example, I put on there a parent charge, but it's the possible charge that it could have. So when I'm asking you to find oxidation numbers, now we can start to look at, say, okay, so when we start looking at oxidation numbers, now we can start messing with, say, oh, I don't know. Let's look at nitrogen. Where's nitrogen at? Look at that. Nitrogen can either be +1, -1, +2, -2, +3, -3, +4, or +5. That's a lot of charges, right? It could be any of those. Okay, that's why those charges are there. However, if it's the only nonmetal, if nitrogen's the only nonmetal in the compound, what charge is it? -3. Okay, and oxygen only has a -2 charge that we care about, and fluorine only has a -1. But once we start to get down here, now chlorine, sulfur, they have multiple charges. So when you're going and finding out or determining the oxidation numbers, the last thing you want to do after you finish determining it is check and see if it's a legal oxidation value. All right, and so that's what we're doing with this. So here's a neat way to determine the oxidation numbers. So here I have a compound of sodium phosphate. Let me blow it up. See, it's sodium phosphate. And I want to know, what is the oxidation number for the sodium, what is the oxidation number for the phosphorus, and the oxidation number for the oxygen. Here's how you do it. You have your compound. Oops, let's use a different color. We have Na3PO4. Okay, that was given to you. The best way to do this is line them up, like Na, phosphorus, and oxygen. And then I want you to tell me how many of each are in the compound. How many sodiums do we have in that compound? 3. So I have 3 of those. How many phosphorus do I have? 1. How many oxygens do I have? 4. Okay. Now what's nice about some of these compounds or some of these elements is that they're always the same charge. Okay. Make it a little smaller. Okay. So when we look at, say, I don't know, oxygen, what's the charge on oxygen every single time? -2. So when you go, whoops, we don't want that. So when we look at oxygen, we can say that, okay, oxygen has a -2 charge. Okay. Looking at the sodium, what's the charge on sodium? Get over there. So sodium's always a +1 charge. So some of these are like dead giveaways where they don't ever change. So we have a +1. Okay. Now, what's neat about this whole compound has a total charge of 0. In other words, the algebraic sum of all these elements add up to equal 0. So we want to make sure that our total charges equal 0. So what is 4 times -2? -8. Good. And what is 3 plus 1? Or I'm sorry, 3 times +1? +3. Okay, so here's the kicker. We want to find, excuse me, some number here that when we add it to +3 and -8, it equals 0. +5, right? So we'll put a +5 there. And how many phosphorus do we have? 1. So that means all these phosphorus exhibit a +5 charge. Here are your oxidation numbers. Now let's check. We know that sodium has a +1, oxygen has a -2. Does phosphorus have a +5? Phosphorus, there you are. Plus or -3 and a +5. It's good. Okay. Let's do one more. Okay. These are the oxidation numbers right here. These are the numbers that you'll find on your periodic table. These are just charges to help you get the oxidation numbers. Do one more here. Okay. Let's look at, we just did copper sulfate. Okay. Let's do copper sulfate again. So we have CuSO4. Okay. So let's line them up. We have copper, we have sulfur, and we have oxygen. How many coppers do we have? 1. How many sulfurs do we have? 1. How many oxygen? 4. And we know that all those have to add up to 0. What's the charge on oxygen? -2, -2. So all the oxygens exhibit what charge? -8. All right, now it gets interesting. Because copper can either be a +1 or a +2 charge. So in that scenario, what we need to do is look at our non-metal. So when we look at our non-metal, which in this case is sulfate, we know that sulfate, SO4, has what charge? -2, very good. So if we know that sulfate has a -2 charge, what must the charge on the copper be? There you go, it's a +2 charge. So we used the non-metal to help us tell what the charge on the metal is. So therefore we have a +2 charge. All right, now we need to figure out what is the charge on sulfur. So what numbers, when we add all those together, equals 0? +6. And then we have to look and see, is a +6 an option for us for sulfur? Right there. Okay. So when you go through this process, and again, there's more than one way of doing this, but this seems to be the easier of the processes. Once you finish, check your periodic table and say, is that a legal charge? And if it is, you did it right. If not, you might want to go back and check and see what you did. All right. Do we need to work any more of these out? No. No? Really? Yes, yes, yes we do, or no we don't?
No, we don't really.
Think we're good?